Hey everyone, welcome back to the channel. Today we're doing a complete RabbitMQ interview deep dive. RabbitMQ is the classic smart message broker, and it comes up constantly in backend and microservices interviews. In this video, we'll cover the 8 topics interviewers love the most: architecture, exchange types, routing keys and bindings, acknowledgements, publisher confirms and persistence, dead letter exchanges, Prefetch and competing consumers, and finally, when you should and should not use RabbitMQ. As always, for every topic, I'll give you a simple mental model, the key technical details, and the trade-offs that interviewers actually want to hear. If you watched our Kafka deep dive, you'll love the comparisons along the way. Let's get started. Topic 1: Architecture. RabbitMQ is a traditional message broker that implements the AMQP model. And here's the key contrast with Kafka. In RabbitMQ, the broker is smart and does the routing work, while consumers stay relatively simple. The core insight is the separation between exchanges and queues. Producers never publish directly to a queue. They publish to an exchange, which decides which queues receive the message based on bindings. The best mental model is a mailroom. You drop a letter at the sorting desk, that's the exchange, with an address on it, the routing key. The clerk consults the routing chart, the bindings, and places the letter into the correct pigeonholes, the queues, where recipients collect and sign for them. That's the whole MQP flow: producer, exchange, bindings, queues, consumers. Now, a queue in RabbitMQ is an ordered buffer that holds messages until a consumer acknowledges them. And once acknowledged, the message is gone. There is no replay of consumed messages like in Kafka. That makes RabbitMQ a natural fit for task distribution and request reply. In exchange, you get rich per message features, flexible routing, TTL, priorities, and dead lettering at the cost of lower raw throughput than Kafka. And for high availability, you cluster the broker and use quorum queues. Topic 2: Exchange types. The exchange type determines how a message is routed from the exchange to the queues, and there are 4 of them. This is a guaranteed interview question, so let's nail each one with an analogy you'll remember. First, the direct exchange. It routes to queues whose binding key exactly matches the message routing key, like addressing a letter to one named department. Perfect for point-to-point or simple level-based routing. Second, the topic exchange. It matches routing keys against patterns with wildcards. A star matches exactly one word, and a hash matches 0 or more. Think of it as a magazine subscription by category. Subscribe to sports.football, and that's exactly what lands in your inbox. Third, the fan-out exchange. It ignores the routing key entirely and broadcasts to every bound queue. That's the building-wide PS system, the classic pub-sub broadcast. Fourth, the headers exchange. It routes on message header attributes instead of the routing key, matching all or any of the set of values. Useful when routing depends on multiple criteria, like urgent plus international. And one bonus detail that impresses interviewers: there's also a default nameless exchange. Publishing to it with a routing key equal to a queue name delivers straight to that queue, which is why simple tutorials appear to publish directly to a queue. Topic 3: Routing keys and bindings. A binding is the link between an exchange and a queue, optionally qualified by a binding key. When a producer publishes, it sets a routing key on the message, and the exchange compares that key against the bindings to decide delivery. This indirection is exactly what decouples producers from consumers. A producer just labels a message, and operators can rewire who receives it by adding or removing bindings, with 0 producer code changes. Think of routing keys as email subject line conventions and bindings as inbox filter rules. Senders just label the subject. Each recipient sets up filters for the labels they care about. Change a filter, and you change what you receive. The sender never knows. In practice, routing keys are delimited hierarchies, like region.service.severity, so topic exchanges can match slices of the hierarchy. One queue can have several bindings, and several queues can bind the same key, giving you both selective routing and fan-out from a single exchange. And here's the senior engineer insight: designing a clear routing key taxonomy up front is one of the highest leverage decisions in a RabbitMQ topology. Topic 4: Acknowledgements and Delivery Guarantees. RabbitMQ uses consumer acknowledgements to know when a message has been successfully handled. With manual acts, the safe default for important work, the broker keeps the delivered message in an unacknowledged state until the consumer sends a basic.ack. If the consumer crashes or its connection drops before acking, the broker requeues the message for another consumer. That's your at least once delivery. The analogy, a courier requiring a signature on delivery. Until you sign, that's the ack, the parcel is still out for delivery and will be reattempted if the courier loses it. Now, the dangerous alternative is auto-ack, which acknowledges on delivery. That's effectively at most once. If your consumer dies mid-processing, the message is already considered delivered and it's gone. It's like signing at the door before checking the contents. A consumer can also knack or reject a message, and with requeue set to false, it goes to a dead letter exchange instead of looping forever. And because redelivery is always possible, your consumers must be idempotent. The same message may be processed more than once. Topic 5. Publisher confirms and persistence. Consumer acts protect the consumer side, but the producer also needs assurance that the broker received and safely stored the message. Publisher confirms provide exactly that. After enabling confirm mode, the broker sends the producer an asynchronous act once it has taken responsibility for the message and persisted it if it's durable. A NAT means the broker could not, so the producer should retry. It's like sending a registered parcel and waiting for the post office's receipt, not just dropping it in a mailbox and hoping. Here's the detail that separates candidates. Durability has 3 independent layers, and all of them must be set. 1. The queue must be declared durable. 2. The message must be marked persistent. That's delivery mode 2. And 3. Ideally, it lives on a quorum queue replicated across nodes. Miss any one layer, and a broker restart can drop messages. For example, a persistent message sitting in a non-durable queue still dies with the queue. Put it all together, durable queues, persistent messages, publisher confirms, and you get end-to-end at least once delivery from producer to broker. Topic 6. Dead letter exchanges. A dead letter exchange is where RabbitMQ sends messages that cannot be delivered normally. A message is dead lettered in exactly 3 situations. It's rejected or NAC'd with requeue false. It exceeds its TTL, or the queue exceeds its length limit. You configure a queue with the X dead letter exchange argument, and such messages get routed to the DLX, which delivers them to a dead letter queue for inspection, alerting, or retry. Think of an undeliverable mail office. Letters that bounce, expire, or overflow the mailbox aren't thrown away. They're collected in a dead letter room where staff investigate, fix the address, and resend. This is the foundation of robust error handling. A poison message, one that always fails, would otherwise loop forever if requeued. Sending it to a DLX after a few attempts isolates it for a human or a separate recovery process, and the original message is preserved, along with headers that describe why and how often it was dead lettered. One more pattern worth quoting in interviews: combine DLX with TTL to build delayed retries. Messages sit in a wait queue with a TTL, then dead letter back into the work queue after the delay. Topic 7. Prefetch, quality of service, and competing consumers. The competing consumers pattern attaches multiple consumers to one queue, and RabbitMQ round robins messages among them, so you scale throughput just by adding workers. But naive round robin can be unfair. A consumer stuck on a slow message still receives a share of new ones, building a backlog while other workers sit idle. The fix is Prefetch, basic.QoS with a Prefetch count. It caps how many unacknowledged messages a consumer may hold at once. Picture a kitchen pass where each chef is handed only as many tickets as they can cook at once. A chef stuck on a complex dish doesn't keep getting new tickets piled up. The expediter hands the next ticket to whoever is free. With Prefetch count 1, a worker gets one message and receives the next only after acting, so fast workers naturally pull more, and slow ones are never overloaded. Higher Prefetch values improve throughput by pipelining, but risk uneven distribution and a larger loss window. The tuning rule: low values for long, uneven tasks, higher values for many small, fast messages where round-trip latency dominates. Our final topic: when should you actually use RabbitMQ? It's the right tool when you need flexible routing, low latency task distribution, and rich per message features, TTL, priorities, dead lettering, request reply, and moderate throughput. The smart broker model means complex delivery logic lives in the broker, keeping your producers and consumers simple. Think of it as a versatile postal sorting hub with every routing rule and special handling service you could want. Where does it fall short? Extreme throughput streaming and workloads that need to replay history. That's Kafka territory because RabbitMQ deletes messages once they are acknowledged and was never designed as a long-term event store. Compared to SQS, RabbitMQ gives you far richer routing and can be self-hosted anywhere, but you have to operate it. Clustering, upgrades, monitoring. So here's your one-line closing answer. Pick RabbitMQ for sophisticated routing and classic queuing. Pick Kafka for streams and replay, and pick SQS when you want zero operations on a WS with simple semantics. And that's the complete RabbitMQ interview deep dive. We covered the AMQP architecture, all four exchange types, routing keys and bindings, acknowledgements, publisher confirms, and the three durability layers, dead letter exchanges, Prefetch tuning, and when to choose RabbitMQ over Kafka or SQS. If this helped, hit like and subscribe. The Amazon SQS deep dive is next, and the Kafka one is already on the channel. For the full question bank with diagrams and mock interviews, head to PrepForge.net. Good luck with your interview. You've got this.